Hello everyone and welcome to the course Advanced Structural Analysis. Myself, Dr. Devesh Ponera, and I'm a faculty at Indian Institute of Technology, Bhubaneswar. I will be the instructor for this course, which will run for a duration of 12 weeks, covering a total 30 hours of course content spread across 60 half an hour sessions. Before going into the formal course content, we would just like to have a brief introduction of the course and discuss about the motivations for this content. Uh, as we look into the progression of the structural engineering program, as well as the basic program in the BTech in civil engineering, the course can be considered as a advanced level course in the undergraduate program. And also it can be considered as a core course in MTech program in structural engineering. In the starting initial years of the undergraduate program, engineering mechanics typically introduces the concepts of rigid objects, the forces, the general concepts of the statics and the dynamics. Beyond this course, the strength of material introduces the concepts of deformable solids, with the discussions around the amount of the stress and the strains in the given object within the framework of the bending, shear, and the torsion forces. As we look into the analysis of the full scale structures, we introduce the structural analysis in most of the places in part 1 and part 2. And it typically caters the general concepts of the structural analysis using the concepts of the beam, frames, trusses in the framework of the general stress resultants, and also tries to idealize these simple forms and analyze them for the unknown set of deformations, the system reactions, as well as the internal deformations or internal reactions of the given system. Through these courses, most of the computations are manual, and there is a need that when we move to the real scale structural systems, we need to understand and we need to comprehensively see a method which is applicable to the full scale structural applications. If we look into the structural engineering and the advancements which have taken place over the years, there are a few points which need to be understood. One, the formal theories of the structural analysis were not necessarily the one which begin with the structural components. Even some of the grand structures have existed even before the formal theories were introduced. This is much due to the standard thumb rules, the intuition, the common sense, and undocumented set of the frameworks, which probably uh, which probably we are not continuing with. At the same time, when we look at to the modern engineering structures, we realize that the number of structural components have increased significantly. The use of the material as well as the application of these structural systems under the severe load like wind, earthquake, as well as the catastrophic environmental factors has been considered during the analysis and design. And all these set of expectations may not be possible without using the analysis approaches which can cater to the real scale structures and also within the more refined framework of the structural analysis. So we understand that there are few challenges which are posed by the regular introductory courses. And now beyond these regular introductory courses, we introduce this course, Advanced Structural Analysis, which tries to answer systematically some of these questions, especially the design of the structures of the real scale by using the computer implementation of the standard structural analysis approaches, understanding the nonlinearities introduced in the system from both the geometrical as well as the material aspects, and then introducing the comprehensive framework of structural analysis, which can be used to analyze the structures of the real scale. The course objective and the course learning outcomes have been defined, which will be good enough to give you a good flavor of the modern engineering structures, the efficient analysis approaches, and at the same time, which will also give us good sense of introduction to the basic software modules which are utilized by most of these structural engineers. The course content has been divided into 12 weeks of the sessions. Initial weeks will be discussing the basic methods of the structural analysis, much of which is covered during the introductory courses. Beyond which, we will try to introduce the concepts of the metrics analysis and spatially focus on the stiffness approach, which is more comprehensive when it comes to the implementation in the computing environment. And towards the later part of the course, we will try to introduce the nonlinear analysis, both from the geometrical and the material nonlinearity perspective. Towards the end of the course, we would also like to have a brief introduction to the finite element methods, which are much more versatile and widely used approaches for analysis of the real scale structures. Some of the references which we will typically follow during the course can be highlighted. It is expected that the course will give a good learning to students in the area of structural analysis by introducing the methods of metrics analysis as well as the nonlinear analysis of the given systems. These methods will not only be used for the general computations, but will also be much more helpful for the real scale implementation of the standard analysis and design approaches. With this, I hope that all of you will have a great learning in this course. Thank you, everyone.